Using the squeeze theorem, we're going to figure out the limit as theta approaches 0 of the function sin theta over theta. And as usual, I encourage you to pause this video and try to figure out what this limit will approach. If you've not watched the first video series on the squeeze theorem, I encourage you to do so, and I'm going to put a link on the description below. Now, looking at this limit, it's not quite obvious, or how to apply the squeeze theorem is not quite obvious. But here with me, I've drawn a unit circle. Now, a unit circle is a circle that has a radius of 1. And here is the angle theta, which is the angle in this triangle, in the smaller triangle, and the angle in this bigger triangle, and the angle in this sector. Now let's figure out what the value of x is going to be. Now, of course, from trigonometry, x is the adjacent side. So if you say adjacent over hypotenuse, of course, from your SOHCAHTOA, adjacent over hypotenuse, that is cosine. So we have cosine of theta is equal to adjacent over hypotenuse. What is the adjacent? We have x over hypotenuse, which is just 1, and x over 1 is still x. That means x is the same thing as cosine of theta. And let's figure out what the value of y is. Now, from trigonometry, we see that this side is the opposite side. So the opposite side over hypotenuse, the opposite side over hypotenuse side is equal to the sine of the angle of theta. So we have sine theta is equal to y over 1, and y over 1 is still y, so we have y equal to sine of theta. And of course, the x is just the length from here to this point here, and y is the length from here to this point here, and z is the length from here to this point here. Of course, note that the distance from here to here is 1 because it is a unit circle, and also the distance from here to here should also, the magnitude of the distance from this point to this point will be 1, and same to this point because it's just a radius, and the radius is the same for every circle. Radius is the same in a circle. All right, so let's figure out what the value of z would be. Now, of course, the length from here to this place is 1. So if we say z, which is this length, over 1, what would that be? Of course, z here is the opposite side. 1 here is the adjacent side. Opposite over adjacent is tan of theta. So tan theta is equal to opposite, which is z, over adjacent, which is 1, and z over 1 is still z, and that is equal to tan theta. So let's figure out the area of, because we know that the area of this triangle here, the area of this smaller triangle here, is lesser than or equal to the area of this sector here, the area of this sector here, and the area of this sector here is lesser than or equal to the area of this bigger triangle here. Alright, so the area of this smaller triangle here will be the half base, which is x times height. So we have half base, which is x. And what is x? X is cosine of theta times height. And what is the height? Y, which is sine of theta. Now this area is lesser than or equal to the area of this sector here, and area of a sector is the angle there, which is theta over 360 or 2 pi. 360 is same thing as 2 pi times pi r squared. Now what is the value of r? 1. So we have 1 times 1 squared. Now the value of this area is lesser than the area of this bigger triangle or equal to it. Now the area of this bigger triangle will be the half base, and what is the base? Just 1. So half base times height. What is the height? Tan of theta. All right, now we have 1 over 2. Of course, there's a 1 over 2 here and 1 over 2 here. Of course, that will cancel out. So we now have cosine of theta, sine of theta is lesser than or equal to theta. Now the 1 over 2 here has been cancelled out. So of course, pi, we cancel pi. So we just have theta here. Of course, 1 squared is still, and 1 times theta is still theta. So we have theta lesser than or equal to just 1 times tan theta, which is just tan theta. And permit me to write tan theta as sine theta over cos theta, which is its value from trigonometry. And let's clean up some things a bit. Right. Okay, so we now have this now. So let's multiply everything by 1 over sine theta. So we have cosine of theta. If we should multiply this side by 1 over sine theta, the sine theta cancel out sine theta. That means, let's do it. So we have sine theta multiplied by 1 over sine theta, then greater than or equal to sine theta multiplied by 1 over sine theta, greater than or equal to sine theta over cos theta multiplied by 1 over sine theta. So sine theta cancel out sine theta, and sine theta cancel out sine theta. So we now have cos theta times 1, which is same thing as cos theta, then lesser than or equal to theta over sine theta. Then this is lesser than or equal to 1 over cos theta. Let me clean this up a bit. All right, so let's take the inverse of both sides. Let's invert both sides. So we have here, we want to have, since it's 1 over cosine over theta, so we're going to bring this up and bring this down. So we have 1 over cos theta is lesser than or equal to, so we have sine theta over theta now. So we have sine theta over theta lesser than or equal to, then here we have cos theta over 1, which is written as cos theta. Now let's take limits as theta approaches 0 of both sides. So we have limit as theta approaches 0 of everything. So we have 1 over cos theta lesser than or equal to sin theta over theta lesser than or equal to sorry for that message, lesser than or equal to cos theta. Now the limit as theta approaches 0 of 1 over cos theta. Now look at, if you look at this, of course, since here is theta, now the limits as the value of theta approaches 0, this line closes up, and the value of x here tends to expand till it gets to 1, which is the radius of the circle. So the value of, as limit as theta approaches 0 of just cos theta alone is 1, and 1 over 1 is just still 1, greater than or equal to. Now we don't know the value of this limit, so we still leave it like that. Limit as theta approaches 0 of sin theta over theta. All right. Of course, the limit as theta approaches 0 of cos theta is still 1. Now, let me write this here. So we have 1 lesser than or equal to limit as theta approaches 0 of sin theta over theta lesser than or equal to 1. Of course, from squeeze theorem, we know that this must be equal to 1, because we have 1 lesser than or equal to this, and this lesser than or equal to 1. So the value of this should also be 1. So therefore the limit as theta approaches 0, let me color code that. So sin theta over theta, this value will approach 1. And to get a more visual explanation, I'm going to show you a graph right now. To get an appreciation for the limit problem we just solved, here I've plotted the graph of sin theta over theta against sin theta. Now from our solutions, we found out that this limit as theta approaches 0 of sin theta over theta, the value of the function approaches 1. Now here I've plotted the graph of sin theta over theta. Now you will see that as we approach theta from the negative side, or from the negative part of theta, if we should approach the 0, we see that the value of the function approaches 1. And if we should approach from the positive direction, we see that the value of theta, the value of the function approaches 1. That means as you approach the 0, as you make theta closer and closer enough to 0, the value of the function approaches 1. Or as you make theta closer and closer enough from the negative side to 0, you see that the value of the function gets closer and closer enough to 1.